Okay, hello everyone. We're going to carry on with fractions this week. We'll do a little bit of a recap and look at it's sort of something similar to what we were doing last week. And then tomorrow we're going to move on to adding, and we might even get to subtracting fractions with similar denominators. So it's going to get a little bit trickier, but nothing you can't handle. And I've been really impressed with a couple of things. Firstly, how well you're doing with my inability to make an online quiz work. You're all handling that really well, so well done. I know last week there was all sorts of issues with spacing and it telling you answers were wrong that were right. And I know I made a mistake on question 1 where I had put the answers in, I think, ascending and asked for it descending. You're managing that brilliantly. I've also been really impressed with the work that you've been uploading. So this week, lots of you uploaded your questions. Some people hadn't used rulers and pencils, but I'll let that go for today. But I was really impressed. So well done, everyone that is persevering. I know it's strange. I know it's not as easy when you're stuck at home and not with the people that you work with on your table groups, but you're all doing brilliantly. So pat on the back to you all. Right. We're going to move just quickly to review and remind ourselves what we were doing last week. So we were looking at how we can make, and I use the word equivalent because that's the way we often describe these. How can we make equivalent fractions? Now, I know that at the moment, these fractions aren't equivalent. They're not the same. Equivalent means equals. But what we're talking about is how can I turn 2/3 into sixths? How can I turn 2/3 into sixths? So what we've got to think about is the relationship between 3 and 6. Let me see if I can find one of my fancy arrows. Oh, got trigger happy there. What's the relationship between 3 and 6? We know that 3 times 2 makes 6. We know the relationship is that it doubles. I could go the other way around and say it halves. Either works. So what I've done is I've had something split into 3 equal parts, 1, 2, 3. To get it into 6, I've doubled it. Each of those 1 parts is now 2 parts. So my 1/3 becomes 2/6. This 1/3 becomes 2/6. This 1/3 becomes 2/6. So now when I'm looking at, and let's color it in, when I'm looking at 2/3, beautifully colored in, if I do say so myself, I've got 1, 2, 3, 4, 6, because double 2, yeah, there we go, is going to be 4. So 2/3 in 6 would become 4/6. So when I'm asking myself, is 2/3 bigger than 3/6? By turning it into a fraction with 6, I can see that 2/3 is bigger than 3/6. Where it gets tricky is if I try and do it the other way around. So if will this work? Almost, yep. If I wanted to go the opposite way around and convert sixths into thirds, then I'm no longer timesing by 2. Instead, I'm dividing by 2. I'm just going to use that symbol for the moment. And dividing by 2, well, that's easy. I know that 2/6 becomes 1/3. So 6 divided by 2 becomes 3/3. I can't divide 3 by 2, but I know that it's going to be 1.5, which is going to be less than 2. So although it wouldn't be a fraction, it does help me work out which is greater or smaller. That was just another way of showing it there. So hopefully that's sort of clear for most of you. I know a few of you made mistakes in the quiz. Most of them were either just misreading the question in terms of whether their fractions were getting bigger or smaller, or a couple of just silly rushing mistakes in your conversions. We're going to carry on looking at fractions, not so much conversions, although there will be some. So let's just have a look at this question briefly. We've got 3 characters here sharing a bar of chocolate. And this bar of chocolate very helpfully has been made to look a bit like a bar model. How many parts has this bar of chocolate been split into? 1, 2, 3, 4, 5, 6. This bar of chocolate's been split into 6 equal parts. Our blue-shirted friend takes 1/6 of the bar of chocolate. So he's taken 1/6 of it, I'm crossing it out, that's gone into his mouth. Our other two friends here are going to share the remaining. And how much is remaining? They're going to share the remaining 1, 2, 3, 4, 5, 6 between themselves. So how can they share that 5, 6 between themselves? Well, here's our bar again, just not in chocolates. We've got 1, 2, 3, 4, 5, 6 parts, and blue shirt's taken 1/6. Our friends here have got 5, 6 to share between them. How could they do that? Can you pause the video and write down the different combinations that each of these two characters could have? How much could yellow shirt have? How much could orange shirt have? What are the different combinations? There's quite a few to see how many you can find. Pause the video now and have a go. Brilliant. Hopefully you paused the video and you'd start to see. You might have used the website that I sent the link for. You might even have just downloaded a fraction wall. Doesn't really matter. What we know is here's 5/6, and I can compare that to lots of different other fractions. So I've got a fraction in thirds. I've got a fraction in 1, 2, 3, 4, 5, 6, 7, 8 ninths, and then I've got a fraction in twelfths. I know that 5/12 fits perfectly. 5/6 fits perfectly into 12ths. I know that because I know the relationship between 6 and 12. So I could stick to just using my 5/6. I could use 12ths. Those would be really easy conversions to make. So I could say that yellow shirt is going to get, where's my pen? She's going to get one of these. And orange shirt, I'm not going to use yellow and orange because it won't show up here. Orange shirt is going to get 4/6. I could change that round and say that actually yellow shirt's going to have 2/6 and orange is going to have 3/6. I could say yellow shirt's going to have 3/6 and orange shirt's going to have 2/6. Or finally, I could say that yellow shirt's going to have 4/6 and orange shirt's going to have 1/6. Those are my options, sticking with 6. And that was just me being logical and starting with one of the characters having 1 and the remainder having 4. Then increasing that 1. If they've had 1 more, then their friend has to have 1 less. So that way I can write down all the possibilities in 6ths. So that hopefully was quite obvious and easy to spot. Where it gets more tricky is that actually we could also deal in 12ths. I could say yellow shirt has 1/12. And then orange shirt has 1, 2, 3, 4, 5, 6, 7, 8, 9/12. I can increase it and say in exactly the same way, oh, now yellow shirt's got 2/12 and orange shirt's got 8/12. And I could carry on down that road, making a whole load of options. And all I'm doing there is splitting each of these bits of chocolate into half. Hopefully you're still with me and I haven't totally confused you, because it's about to get even more tricky. I could be even more unfair. If I was yellow shirt, I could be a proper greedy guts and say, right, I'm going to take 2/3 of the chocolate bar. Now that doesn't leave 1/3 for orange shirt. But when I look up, 2/3 comes to here. And I know this is the amount I had in my 5/6. So then orange shirt would be able to get 2/12. So I could be splitting my remaining chocolate bar up into fractions with different denominators. Don't worry if you didn't get to that stage. Don't worry if that bit's not making total sense yet. For some of you, that will make sense. You go, oh yeah, wow. For others, that might be a little bit step too far at this point, but later on this week, I think that will sink in and make sense. And we'll come back to this briefly later in the week. So don't panic if when I started talking about thirds and 12ths, you started losing me and thinking, what on earth is he talking about? Right. So for the rest of the lesson, we're just going to really focus on keeping the denominators similar. So here's another example. Oh, let me get rid of my pen. In fact, let's go to the big screen. I keep forgetting. There we go. So I've got an unknown amount of fifths and an unknown amount of fifths make 4 fifths. Here you can see 4 fifths are coloured in. What possible combinations are there? Again, fractions, always put it into a context, whatever context you want. 2 people, we know there's 2 because there's 2 fractions. 2 people sharing a bar of chocolate, a chocolate bar that's split into 5 equal pieces. Pizza, cake, broccoli, whatever it is, doesn't matter. But if you picture it, it makes it simpler. So if I've got 2 people sharing fifths, how can I do that? It's got to equal 4. This is where lots of you might get yourselves a little bit confused if you're not concentrating. The two people's parts, the amount that each of those people have, makes in total 4 fifths. So one person can't eat 2 fifths and one person eat 3 fifths because they've only got 4 fifths. Oh, I've exited that and I need to make mine. There we go. So probably lots of you are saying, oh, well, that's easy. One of them could have 2 fifths. One of them could have 2 fifths, and that equals 4 fifths. Everyone's happy. Yeah, absolutely. Nice equal split. We can split those 4 bars of chocolate into 2 equal parts. Great. Are there any other ways we could do it? Pause the video and have a think. Excellent. You might have realized that one person could have 1 fifth and the other person could have 3 fifths. And in fact, we could have switched that round. The first person could have 3 fifths and the second person could have 1 fifth. There's not really any other options if we're keeping the denominator as 5, unless you're going to go down 0 fifths. We'll leave that for the moment. Some of you might have realized that actually you could start playing around with the denominators here. We could split these fifths in half, and then there wouldn't be 5 equal parts, there'd be 10 equal parts. And that throws up loads more options. So you might have done that. You might have said, for instance, one person's still going to have 2 fifths, but the other person, rather than having 2 fifths, is going to have double that, 4 tenths. And that would still equal 4 fifths, because I know that 4 tenths is the same as 2 fifths. So you might have got a bit fancy and done some doubling of the parts, making them twice as small and twice as many of them. Don't worry if you didn't do that. In today's lesson in the workbooks, you're going to be focusing on questions where you're keeping the denominators the same. But I know some of you have been finding the fraction works quite easy, and so you might want to look at mixing your denominators. If you're not someone that's finding this part with keeping the same denominators really simple, then stick to keeping the denominators the same. But if you're looking for a bit of a challenge, you can mix the denominators up a little bit. Right. So let's try another one. This time, it doesn't tell me what the denominators are. I've got 2 fractions that make 7/9. So I've drawn my 7/9 out here. And for those of you that are going to look at different denominator fractions, I've also put some other fractions up here. But let's just stick for now with having the same denominator. Well, 7/9. How many different ways could I make 2 fractions make 7/9? Pause the video and write down some of the combinations. Brilliant. Hopefully you've started in a logical way rather than just guessing loads of numbers. And you've started saying, right, well, one of them could be 1/9. And then the other one would be 6/9. My next option would be 2/9 and 5/9. Then 3/9 and 4/9. And then you'll start to see that actually the pattern reverses. 4/9 and 3/9, 2/9 and 5/9, etc. Some of you might have started playing around with mixed fractions. That's fine. You might have done things like 1/2. No, not 1/2. What did we do? We could do 2/3 and 1/9. You might have done 1/3, and no, you couldn't do 1/3. What could we do? So you'd have to look. If you're trying to do this, you've got to look at where the lines match up to the ninths. So I can see that my 1/3 line matches up, my 2/3 line matches up. So I can do 2/3, that matches there, and I've just got this gap here. Ooh, go away. I could do 1/2, but then that doesn't match along here, so that makes that a bit trickier. And I can't do 1/2. So you might have played around with some other options. Obviously, ninths, we could double that and go to 18th, making these all half as big. So if you have tried with different denominators, that's fine. And a fraction number, my brain's not working. A fraction wall is a really good way of visualizing those combinations. Right. I know that I'm trying to, in this lesson, give some of you tasks with the same denominator, some of you tasks with different denominators. So it might have been a little bit more confusing. Hopefully not too bad, and hopefully you've managed. I'm going to ask you to go to the worksheet, and I put the links on the daily PDF. The worksheets are asking you to look for fractions that have the same denominator. However, once you've done the fractions with the same denominator, if you want to give yourself a challenge, then you can look at doing some of the questions with different denominators. So the worksheet is expecting you to use the same denominator for the question. So here I've got shapes split into 1, 2, 3, 4, 5, 6, 7. So I know that's 1/7. I've got 1, 2, 3, 4, 5, 6, 7. So I know this is 5/7. 1/7 plus 5/7 makes 6/7. That's what the worksheet's asking you to do. Put one of the fractions for the first bar in here, for the second bar in here, and then plonk them into this number sentence. As I said, if once you've done that, you want to have a challenge, then start looking at 6/7. How else could you make it? Right, pause the video here, and then I'm going to get you to come back to the video to check the answers out. Brilliant. Hopefully you have paused the video. So I'm going to pop the answers on. So just have a check of your work. Make sure that you haven't made any silly mistakes. If you have, it's not a big deal. Just make sure you know what mistake you have made, because then you're less likely to make that mistake again. And let's look at the second page. Brilliant. Okay, that's it for today, and I will see you tomorrow.